the video streaming has started. This is Jan Nieuwenhuizen, who actually started with Geeks, introduced to Geeks last FOSDEM, and is now a major contributor. So welcome, Jan.
Thank you. Yes. Well, I was a major contributor, but my talk is about something that has to do with Geeks and is not Geeks. It has derailed my contributions a bit. I've worked on the cross-compilation infrastructure, specifically building MinGW cross-compiler, and had a lot of help and fun from Manolis, who's working on the herd. His talk is next. But this is something completely different. I was inspired to look at Geeks last year. I started playing. I was running Debian, and I've run Geeks for Geeks as a package manager on Debian for I think 3 or 4 months, and in that time I migrated all the packages that I needed for my own development and for my client's development that I write software for, until everything was packaged in Geeks, and then I took the plunge. That's a nice way of doing it. Going off the deep end can also be inspiring, I guess, because using Geeks on Debian can be done, but it has fragility aspects. So I don't know. So when I started doing, so what is MESS? MESS is full source bootstrapping. So what is bootstrapping? Do I need to explain that here for who doesn't know about bootstrapping, the bootstrapping problem? Okay, most of you know. So it's the question, where do compilers come from? Who compiled the compiler, or the chicken and egg problem? How am I going to do full source bootstrapping? My idea was to write a tiny scheme interpreter in hex or in simple C, and there it gets fuzzy. That's why this talk. And when I have the scheme interpreter in hex, what do we do? In scheme, I write a C compiler, and the C compiler then compiles GCC or maybe Guile, and that's another messy point. Maybe you have ideas. And when MESS has a C compiler, then we have MESSCC, which is the name of the C compiler. So I have something that actually works, but I look at it as being a strategy to test things out, and there are many decisions that could be made, and for me I need something that works to be able to see the next step. So it's not a goal in itself. I have something like a proof of concept. It's not a general purpose scheme, although it has aspects of being close to R6RS, and it has major gaps, and it's not an alternative for Guile, but I'm loading and using Guile modules. So Piotr said it, inspiration, that's what happened to me last year. Inspired by Geeks, but now I'm doing MESS. So what do you want? So as a human being, a hacker, I'm looking for meaning, for autonomy, but also co-creation. Want to do something meaningful and fun. So one of the great things, and if the goal is greater, then my inspiration rises. So an inspiring goal for me is a planet of enlightened beings. Why not? So what do? I look inward. I try to be happy and try to be helpful. Another crazy idea, which goes in the same direction as far as I'm concerned, is a world where all software is free. Totally crazy idea. What I do is I support GNU and I create free software. So, why am I here at this talk? Geeks really inspired me. I've looked at the herd 10 or 15 years ago, and I wanted to run GNU, but I didn't manage it. And Geeks feels to me like running GNU, finally. So I just had to do that. Yeah. The four freedoms. If you don't know them, read them. It's terribly inspiring for me. So that was the seed, the four freedoms by Richard Stallman got the whole thing started. A lot of things happened, but in 2013, before I knew about it, Debian started the reproducible builds or repro builds project. It didn't have that website, but the idea was, well, I want to all software is free, but how do I know that the binary that I run actually was produced from the source that is free? Is there any way to ascertain that? Well, you can study the compiler and you can see what assembly comes out, and you can but that's very cumbersome. You will have to do that if you compile the program twice. You would maybe have to do that again because it looks different. So reproducibility gives you a very easy test whether if you cannot reproduce the same binary twice from a piece of source code, are there differences? Are they interesting? How are you going to do that? So I thought repro builds is a very inspiring idea. And then Geeks came along, and I have a small summary here for why repro builds are so nice. Actually, there are a means to an end. We want autonomy and safety. That's basically it. So how did we get here? Why is reproducibility and Geeks so nice? Well, of course, we had NixOS, who gave us functional package management, and that made it possible to go, or very easy to go from source to reproducible binaries and have the full list of dependencies and be bit for bit identical. Identical. And one of the great things about Geeks as a user is something that I like to call binary and source transparency. You can, if you have a program, it's very easy to package that and deploy it only for yourself. It's almost no effort, but you cannot distinguish it from the rest of the system. So philosophically, when you install a package, you build it from source, but usually we use the binary substitute, which makes it a bit quicker. But I will get the same binary as I would have gotten if I had built it from source. So it feels like building from source, but actually, so everything feels like building from source. So that's great. We have GNU, we have all source, we build everything from source. But there's this bootstrap binaries thing. And that annoyed me. It's only a tiny speck. I mean, everything is source, everything. So here's our bootstrap graph, which is in the manual. So what are we talking about if we talk about bootstrap binaries? It's too small to read here, but it's a dependency graph to build the first bootstrap binaries. And here's in text. I was wondering, well, what kind of binaries are we talking about? It's only 28 megabytes zipped. So the bootstrap binaries are 200 megabytes. It's not a real problem. We can reproduce them, and we do that. But it seems terribly big to... I was wondering about that, and then Orions J came along and told us about his hex assembler, a self-hosting hex assembler. And I thought, wow, that's great. If you have a self-hosting hex assembler, maybe we can do away with all sources. But I was still going hex and then the C compiler, and I didn't really see it. I'll just skip this bit. So I was looking at the bootstrap problem, and there was the hex assembler and the bootstrap binaries. It would fit in Geeks, but I didn't see it. And then I stumbled upon an article from Alan Kay, an interview with Alan Kay, where he said, the big revelation to me was when I finally understood that the half page of code on the bottom page of the bottom half of page 13 in the Lisp 1.5 manual was Lisp in itself. These were the Maxwell equations of software. So I thought, if you want to bootstrap a system and you want to do that in the most convenient and small way, well, then maybe use something Lispy. So shortest path from hex to GCC is obviously using the Maxwell equations of software. If they are really the Maxwell equations, then it should be the prettiest path that you can imagine. Otherwise, we have to look for better equations. So that's where the mess comes in. So I looked up the article, and this is the bottom half of page 13. And to be honest, I had a copy of SIGP, and I read some stuff until the exercises come, and then I gave up. So there's this evil apply thing in the wizard, and I was going, I don't know, am I a wizard? An evil apply, what does it mean? So it looks interesting, but I need to see it and play with it to get a feel for what it does. But I was inspired enough to try that, and naive enough. So this is eval and apply. And what happens is, well, you want an expression evaluated, you give it to eval, and eval says, well, it has multiple components. The start could be a function, so let's evaluate that. And the parameters should be evaluated, and then hand it to apply, and apply will say, oh, that's a function, let's execute the function, something. And so you have some primitive functions, char, cooter, cons, atom. It's very simple, but it's not hard to imagine to add a built-in or a primitive function and extend this guy with C functions or something like that. So you have eval and apply in the core, and then you have some helpers which are not really interesting. They're interesting, but they're not interesting. So assoc, parallels, fcon, and you have the primitives atom, char, cooter, cons, and eq. So this is the first thing I wrote. I just started to type that in Guile. I made a module where I removed everything from the Guile module and tried to make sure that I was only running this. So here you have apply. It's literally the same as on the page 13. And there is eval and the not so interesting functions. So, great. I can write my own eval and apply that can execute only the basic primitives, and I can write it in Guile and execute it. Beautiful. So the next step was to write it in C. Well, I need to go to hex, but that seemed to be a too big step, so I decided to cheat and start with a C implementation, a C prototype. And very soon I found out that Lisp 1.5 is really nice, and I had this eval apply layout until the beginning of December, and maybe I still want to go back to that. But first I wanted to bootstrap using Lisp 1.5, and then on top of that implement a full scheme, because these really are the Maxwell equations. I have a prototype that does that. So then in scheme you would extend, add macros and stuff to eval and not touch these Maxwell equations. But that really didn't perform, so I started messing with the Maxwell equations. And you have something like closures and difference between symbols and keywords and specials, and how do you do macros, and well, there's this syntax rules thing. So what I wanted to do is, when I had the thing running in C, I wanted to have my own C compiler. So first, shortest path to success, dump an ELF binary that I can execute, starting from a simple main function in C. And Rutger, who is sitting here, I've had a lot of help from him describing my problems. He said, well, what you're doing is great, but you need a garbage collector. And I said, well, I don't know. I bought 16 gig. Let's see. So I took SIGP, and I started reading about the garbage collector, and then I read a footnote from Abelson and Sussman where they say, well, maybe memories may get large enough so that it would be impossible to run out of free memory. And I thought, well, great, let's go for that. So then so here's my minimal NCC parser. So I had to extend I extended the prototype in C and a lot of functions in Scheme, just enough that I could run the Luller parser by Dominique Boucher, and I could parse this guy and dump an ELF binary and run it, and it would print "Hello World." That was in August, and I was going, whoa, now I'm done. Well, it's not totally true. The mess could run the Luller parser, and it could parse a simple, a very, not C, but a simple parentheses example. And when I wanted to parse this guy, it segfaulted, and I couldn't there were a lot of problems that I fixed, but it kept seg-faulting. It ran for 5 minutes and then it seg-faulted. Well, turned out that when I accidentally ran top, in 5 minutes it was consing through my 16 gigs. So then I came back to Rutger and I implemented the garbage collector, which took me 2 months to get all the bugs out. But now I could look at NIAC, which is a full C parser that we have. Well, we have. And I should speed up, I guess. So where are we now? We have a full C parser, and what I'm doing now is writing the. I have a smaller version of MES, which is 700 lines of C, and the compiler that I wrote in Scheme can compile that guy, and it can. So where are we? I'm just skipping ahead here. It's called the tiny version of, I divided the problem up in smaller parts. I have a tiny MES, which is a C compiler that can be executed by MES, and it can read a dumped file, which has an S expression and can print it. So MES can compile a C program of 300 lines that does that. And then I have the next step, which I'm still working on. This guy can sorry about that. The C compiler in Scheme, when I execute that with Guile, can compile a binary that runs this. It reads an S expression that reads cons 01 and execute that and give the cons. MES cannot at the moment do this, and I'm working on that. There are some statements that are still not parsed by MES. There is a Geeks package. It's not in Geeks itself. I wanted to have the compiler really working so that it's self-hosting. Expect that in 1 or 2 months to have a self-hosting C compiler in Scheme. Yes. So where to go next when we have that? Is that useful at all? That's actually my biggest question. I can imagine it's nice to have a C compiler in Guile, but a serious C compiler project in Guile would mean that if I use that in MES would have to be more mature, and I don't want to rebuild Guile because we already have that. So maybe make Guile so easy that it can self-host itself. I don't know. And then there's Chris Webber who said, well, you have the... have you looked at pre-scheme? Because your prototype is in C. Why not start from a scheme-ish language where you have a compiler anyway? So take the work on pre-scheme and don't throw away the C, the C source.
You should probably explain what pre-scheme is, because I don't think many people.
Oh yeah. Yeah. So pre-scheme is a subset of Scheme, which is part of Scheme 48, and Scheme 48 will take pre-scheme and compile that to C. And then the C is compiled, so yeah, scheme is taken as a source library. But as we have a C compiler, we don't need to go to C. We can take that as an intermediate stage. Yeah, so that's what I'm trying to do. Get rid of the bootstrap binaries, and I have something that works, but I'm wondering if it's useful at all and what the next smart step could be. So, questions?
So we have time for questions, and then Manoli should set up, right?
I would like to thank you and say it's very important what you're doing. I mean, my dream is exactly the same thing, to have a self-built hardware and running fully bootstrap software like this. There's only one programming language it's superior to Lisp, and sometimes when I work with it, it's Form. Because what we do, just write a little assembly thing, little interpreter, you keep it run versus byte code. So my suggestion, if you want to play with them, I would write 3 assembly versions for different platforms like ARM, Intel 32-bit, 64-bit, and bootstrap from this, and try to get the Lisp running out of this assembler, like mini Lisp. And because the only reason you need C is portability, right? So
yeah.
It would be actually much cooler to have a little machine code bootstrap running micro Lisp, pre-scheme maybe, I don't know, whatever, and then just running from there, and you can. Well, because C is just your portability layer.
Okay.
Thank you. I think it's
Thank you.
It's very important.
Let's talk about that. Yep.
So did I get it right that the ENIAC compiler running on Guile can compile MES, right?
Yes.
But the ENIAC compiler running on MES can
sorry. No, it can compile the tiny MES thing, the thing that reads the as expression and display it. The one that runs cons needs some more constructions in C, but that's just more work.
Okay. But anyway, I agree with what was said. It's really important, and I appreciate what you're doing.
Thank you.